Hi guys, as I see it as about 33 minutes past, so we are going to make a start. First of all, I'm new to this technology. My role until recently has been to go out visiting schools and colleges and universities to help them with their curriculum. Until recently, obviously, I'm not really allowed to go to see any institutes at the moment. So I am having to get used to doing things like this, webinars and doing things online, and it is, it's cool. I like it. So I will say, if you do struggle to hear me, I have muted you all. So if it's something more pressing, if you could unmute yourself and say either you can't hear me, or if you've got a question, unmute yourself and ask that question straight away. For questions that could wait, I will do a question and answer at the end. So if you do have a question, if you could put it in that chat, and I will answer it at the end, unless it's something more pressing. So yeah. So how we're going to structure this, I'm going to do a short presentation on what the Unit 6 microcontroller, an overview of that unit. And then I'm going to go into detail on how Matrix and our company can help you, whether that's software, hardware, curriculum or online support, on how we can help you with that unit. Then I'm going to do a demonstration of our software, and then I'm going to show you some of the hardware as well. So without further ado, I will get on with the presentation. I will have to swap over the microphone and share my screen with you guys. So that might take 30 seconds. If you bear with me, that would be fantastic. Thank you. Bear with me, guys. Okay, guys, so you should now be able to hear me. Unmute yourself if you can and say something. Okay, so an overview of the new unit. So this chart here is taken directly from the Pearson's BTEC specification for the new RQF. Okay, so running down the left here, you have all of the specific units. Next, you've got the guided learning hours. You'll see straight away the Unit 6 here. The unit size is a double unit. It's 120 hours. Not only is it a double unit, we can see here for your engineering, electrical people, mechanical, computer engineers, aeronautical, automotive, manufacturing, it's mandatory if you're doing the extended diploma. Okay, so if you're doing the normal diploma, it isn't mandatory, but the extended diploma, it's a mandatory double unit. So 120 guided learning hours. So it's a big unit. This is a massive change. So in the previous specification, there was actually an optional singular unit for microcontrollers. I think it was 59. I might be wrong. It might be 69, but it's one of those two. But now they've actually, BTEC and Pearson's have made it a mandatory unit. So you know that is a big change. I regularly meet people, often mechanical people, who are teaching the mechanical engineering extended diploma, who actually, what's a microcontroller? They don't even know what a microcontroller is, and they're looking for a lot of help and support. I guess the good news is there is a lot out there. We do offer quite a lot of support, particularly with this unit. Okay, so how can Matrix help with the Unit 6? We've got a four-point attack essentially. The first way is we have a range of hardware called eBlocks 2. Again, some of you may know a lot about this, some of you may not. So I will go into detail with each. Another way that Matrix offers support and help for this unit is our software, Flowcode. We're currently on version 8 of Flowcode. Now, we also offer courseware, so we've got a complete guide. I will go into detail into all these four. But another way that we can support is training and support. Okay. So this chart, again, is taken directly from the Pearson specification. Okay, so you have got choice here. The hardware, you've got a choice between Arduino or Genuino. Genuino, I think, is the American version of Arduino, I think. PIC, then you've got Pickaxe or Genie. So in terms of what Matrix offer in terms of hardware, we only offer Arduino and PIC. We don't feel that many colleges or institutes will be opting for Pickaxe or Genie because it's nowhere near as industrial as Arduino or PIC. It's a lot more hobbyist and educational. So that's why we support Arduino and PIC, which is a lot more transferable into industry. Okay, so once you've selected your hardware, you then have an option. You can go with something like Flowcode, which is our software, or you could use that, and that's available for PIC and Arduino, and is written into the specification as a recognized, a good language to use. Or you can use the MP Lab for PIC or Arduino IDE for Arduino. Okay, and in the right column you'll see that it stipulates the programming language has to be either Arduino C or a flowchart. We can help you with the flowchart side of things here. So, our hardware, I'm going to talk about our hardware, eBlocks 2. We're currently on the second version. Its predecessor was eBlocks 1. This is now eBlocks 2. It's the latest version. It's been out for about 2 years. And eBlocks 2, it's a modular system for learning about microcontrollers. It takes a microcontroller and it puts it into a flexible sort of building block format, where you have a motherboard and then you have a range of other boards, downstream boards, so things like sensors, screens, LCDs, switches, up to things like Wi-Fi and beyond. And this system, it's affordable, it's long-lasting, it's ideal for the educational environment because of how rugged and long-lasting and easy to put together. And it's got great integration with our software. So the students have the perfect platform to learn the basics through to the more advanced system programming required for engineers. So the real benefits of using eBlocks is the flexibility through its modular design. Users can very quickly and rapidly put together a system in a small and compact solution. And we see that this lasts for years and years. So, PIC or Arduino? Well, in terms of how we can support you, it doesn't really matter. To be honest, when you're using our software Flowcode, PIC is probably a slightly better option. It has one less step before you compile to your microcontroller, but that is the only difference. I think Arduino may be slightly more expensive, but you're talking maybe £2, £3, £4, £5 more. It's negligible. So we can support with PIC or Arduino, and we don't mind which you use. We have them both covered, and this is totally up to you to decide which best suits you and your needs or your local industry's needs. Historically, PIC was always slightly more industrial. But I think now you could argue that they're pretty much on a level playing field industrially. Arduino is probably more in the hobbyist market, but we probably have seen 50-50 in terms of what we've sold to colleges. If I could recommend one, I'd probably say PIC, but again, totally up to you guys. So whether it's PIC or Arduino, when the changes of the BTEC were announced and this new unit was published, our engineers and our researchers here at Matrix, we looked into the specification for Unit 6. and developed a kit called the Microcontroller System Development Kit. And again, we do this in a PIC flavor or an Arduino flavor. This is basically a complete kit for all that you will need to get through the exam for Unit 6. And it comes in one rugged storage solution, like it's in the Grapnels format. So whether you go for PIC or Arduino, it comes with the motherboard, and this is backed up on a printed panel. I will show you this, guys, after the presentation. So it comes on a rugged baseboard and panel to make it as student-proof as possible. And then it comes with a complete set of downstream boards. So included in that is there's a relay, keypad, there's an LED, LCD screen, there's a couple of switch boards, there's a 7-segment display. It comes with an actuators training panel, which is here. And that includes a DC motor, a stepper motor, and a servo motor. It comes with a prototyping board and then a range of sensors which attach to the sensor's motherboard. So on there you've got things like there's an ultrasonic range sensor, temperature, humidity, infrared, there's a buzzer as well that attaches to that, and there's a potentiometer and a light sensor. Okay, just a reminder, guys, if you have any pressing questions, please just unmute yourself and I will answer them as we go. Alternatively, if it's a question that can be answered at the end, just put it in the chat and I will make sure that we have time to answer them at the end. Okay, so that's the hardware. Now we move on to Flowcode. What's Flowcode? Flowcode is our software. So we've designed Flowcode, and it's a programming software that simplifies the process of programming microcontrollers. In this case, it simplifies the process of programming your either Arduino or your PIC to satisfy the exam at Unit 6. Okay, so the learning of C code, the language of the microcontroller, can be very, very challenging for students, particularly perhaps your mechanical students. And in Flowcode, the user writes or creates a flowchart, and Flowcode in the back converts the flowchart in, which is a logical step-by-step sort of set of commands, and it converts that flowchart into the language of the microcontroller, which is far more complex than you know, a flowchart. Anyone can create a flowchart within reason. So drag and drop flowchart, anyone could sort of do that. Not everyone can code or has the ability to code. So it really is a way of an intermediate step. Flowcode acts as an intermediary and converts the flowchart into the language of the microcontroller. I will do a demonstration of Flowcode after this presentation. So, Flowcode. Flowcode is an advanced integrated development environment, or an IDE. Flowcode is ideal for people who are not comprehensive in C coding. It allows users to make complex systems very quickly. And that's one of the reasons why we are very hot in industry. We've got thousands and thousands and thousands of industrial customers that basically, they may do programming once, twice a month, and they don't want to get bogged down with the C code. So all they do is they use Flowcode to create their program and make sure it works before they get into the C code. So it's for rapid prototyping. They don't want to get bogged down in the C code, and they just need to see something that will work. Okay. Another great thing about Flowcode, which the IDE of Arduino and PIC doesn't have, is that it's got very powerful simulation features in both 2D and 3D. This is a lot more intuitive and easy to learn using than something like C. But it's also a great real-time, time-saving tool, because you can simulate everything on screen before you actually compile it to your chip. So you can make sure it works before editing it a bit more. And then when you're finally ready that it works in simulation, now let's see it work while we use our hardware. So specifically when we're doing the Unit 6 exam, which is time pressured, remember, the using Flowcode will save you a lot of time in even just by its simulation features. Okay. So Flowcode also has inbuilt test and debugging tools. So
You can do a lot more debugging, and there's a lot more feedback than if you were to use something like C code. So if you've got errors or syntax, Flowcode will do a lot of the work in terms of test and debug. For students that do want to learn C, that's no problem, because you can actually input C in Flowcode as well. You can create your flowchart and you can see the C code side by side with the flowchart. That's something that I will show you after this presentation. Something also which is a bit of a hot topic at the minute. When if you are to buy Flowcode, we do it in packages of 1 user, 10 user, or 50 user site license. You will actually automatically get home user licenses as well. So if you would buy a 50 user license, you get 100 home user licenses. At the minute, the students may be restricted to the time they have in college or in university. So the distance learning side, the student home user licenses is a real great way of setting tasks and asking them to do that at home. And those 100 licenses actually refresh after every cohort. So once your cohort leaves, or we can refresh that, and it will go to the next cohort. Okay. So why would you not just use Arduino? I mean, Arduino is a fantastic platform. It's got a very large following in education and hobbyists around the world. However, there are also many downsides. So firstly, it's very hard to write in Arduino C. It comes with a lot of syntax errors that learners will easily get distracted by. If your student ends up spending most of the time fault finding, with things like having to wire their own circuits using Arduino, our option comes with plug and play. You can literally plug your components together and make a system. With Arduino, it's more hard wiring, which will lead to problems like, actually, let's do some fault finding on the hardware rather than the software and rather than the programming. So with using eBlocks, you're literally plugging something in. There is no sort of hardware issues. Arduino, it could be more focused and time consumed on, let's find out what the problem with my hardware is, or they might not even know there's a problem with the hardware, which will make it even more frustrating when they believe that they've got a program that should work with the hardware. Okay. The other thing is with Arduino is it isn't totally built to last. They are seen more as a bit of a disposable product, which maybe after a year or so, after a lot of use with your students, particularly with your exams and things like that, you might start to see wear and errors creeping into your classroom. Okay, so the support with Flowcode and eBlocks. Okay, so firstly, we have a very, very big following on our forums. These are actually manned by our engineers. There are thousands of questions which are all answered there, and the engineers that work for BTEC aim to reply to questions in around 24 hours of the post appearing on the forum. So if you can't find the answer to the question already there, if you insert the question on the forum, we reckon within 24 hours-ish, we will get you an answer. Okay, so that's one level of support on Flowcode and eBlocks. Secondly, we also have a lot of free courses. I will go into one specific free course, which is written around Unit 6. I will go into that specific course later, but we have a lot of free courses on our website that are freely available even now. Okay, just going to have a drink, guys. The next one, we have a centre which we've written articles and things like that for students or teachers to go on and see, exemplars and things that are useful. So we've got an article section. We also finally have a wiki resource database, which is basically the FAQs that we've had historically, or that we think that will be useful to you guys, and we've actually gone on and answered them. So there's 4 main ways of support for Flowcode and eBlocks. But I think for you guys that are delivering Unit 6, the most relevant one I will come I will come on to next, and that is the curriculum that's written around Unit 6. So here we are, guys. This is as it reads, suitable for BTEC National in Engineering Unit 6, Microcontroller Systems for Engineers. So when the changes to the BTECs were announced, we actually wrote this complete workbook, which is very thick. I think it's about 100 pages. And it includes the lesson plans for your teachers. It includes teachers' notes for your lecturers. And it includes student handouts. And everything you need to be able to get to the end point where you're taking that exam for this unit. So this curriculum here is actually 100% free. You can go on our website right now and download it. It comes as a PDF. You can put it onto your VLE. You can print it out. You can put it on your smartboard when you've got students. You can do whatever you want with this document. I will actually send you a link to this document in the follow-up to this to this webinar. I'll send you a link to that document, but it is very, very thorough. I actually have some customers that are very mechanical orientated that came to me when these changes were announced a few years ago, and they didn't know what microcontrollers were. Now, they bought our software, they bought our hardware, and they downloaded this booklet. And actually, I speak to them from time to time, and they're actually, every time they deliver a lesson in Unit 6, they're 1 or 2 lessons ahead of the students. So they basically do the lesson themselves, and then they give that lesson to the students. So they're 1 step ahead of the game, and that kind of works for them. And they've got great results on the back of this unit when they've done their examination. So, you know, that is one way of doing it. Okay, now finally, one way we can help you, or have been able to help you previously, is with training. Now, historically, before current issues, you know, we had COVID, we would go on site or people would come here and we would deliver training. Now, obviously, at the minute, that isn't an option. Okay, so but that's not, you know, to say we can't do training. We are happy to spend, you know, few hours with your lecturers or people delivering this unit. We are happy to spend a few hours over Zoom, like we're doing now, over Skype, getting everyone ready, getting everyone set up, getting everyone used to Flowcode. You know, we're happy to do that. So if that's something that you'd be interested in, register your interest with myself, and we will go from there, because you know, this unit, I'm sure for a lot of people could be quite a daunting task. Okay. Okay, so that's the end of my presentation. I'm now going to give you a quick demonstration of Flowcode. Let me just, give me just a moment. Bear with me. Just getting used to the software I'm using, guys. So, when you open Flowcode, this is a typical screen. The first thing you have to do is you have to select whether you're opening a project, so something you've done in the past, opening a template. We have several templates on there that you may use, or if you're starting afresh. Because I want to show you guys from the beginning, I'm just going to start it afresh. So you go to New Project, and then you click Embedded. Now, the next step is it's going to come up with a series of different microcontrollers that I can choose. So a lot of microcontrollers are supported with Flowcode. Now, you'll see there on the list there is Arduino. For this example, I'm just going to use this one because it's one I've used before. But if you were to use Arduino, you'd click Arduino, then select the Arduino you have. So I'm selecting this particular microcontroller, and then this is a typical screen in Flowcode. Okay, so this here on the right is what we call the 3D system panel. So this is where you will see all your simulation. Running along the top here, just like you'd have in Word or PowerPoint, is, you know, opening files, editing files. But then you've got macros, you've got debugging, and you've got building. So in there, If you click build, this is where you could compile to C or hex or view the C code. And here is where you would select an input, so any switches or maybe some sensors and things like that. Here you've got outputs, so you've got LEDs, you've got some mechanics there as well. You've got all your outputs will be there, except your displays, which are here. Oh, sorry, in your inputs, that is switches, toggles, potentiometers. It doesn't actually include sensors because we've got a section here for sensors. So in there, you've got your temperature sensors, you've got your color sensors, touch screens, that sort of thing. And then I won't go into any further detail, but you've got data there, you've got communications there, so Wi-Fi and things like that. This is your typical, if you're using pure E-blocks, that's where you'd use that. Okay, so for this particular, I'm not actually a coder. I can get by with Flowcode, I can do bits, but I'm not a massive, coder. So all I'm going to do for you guys is something simple like get an LED to flash. Okay. So firstly, I'm going to go to outputs. I'm going to select an LED and I'm going to drag that to this 3D systems panel. Bear with it, my laptop's pretty slow. Okay. Now I can zoom in on that and I can turn that round. There you are. Now the next thing I need to do is I need to tell the system where this LED is. So on our boards and using the curriculum, it will tell you the best thing to do. So I know because I've done it before, that this should be connected to the port B. On our hardware, it will actually show port B, but just so you're aware, it is on port B. Then I would select number 2. So it's pin 2 of port B. So here I'm going to get rid of the properties now because I don't need that. This here is where you will see your flow chart. Okay. So you're running down here, you've got all your flowchart commands. So input, output, you've got, that's a delay. You've got a couple of decisions there, switch, connection point. There you've got a loop. There's your macro, component macro, simulation macro. You've also got calculations there. You can input C. If anybody is at a level they want to input pure C, again, you can just drag and drop that there as well. And at the bottom there, you've got a comment. So, if you've got any sort of comments that you want to make for next time so you remember something, you can insert comments as well. So I want to make this LED flash. So something simple. I'm going to grab this output because LEDs are outputs, and I'm going to drag it there, okay? Oh, but by the way, all flowcharts have a beginning and an end, and you just need to add something into the middle. So I'm going to click on this output. And as I mentioned earlier, I need to tell it that it's port B and it's a single bit number 2. I don't want the whole port to light up or to register. So now I need to say that I want the light to flash. I want it to turn on. So I change the variable to 1. Okay. And I click OK. Now here the flowchart is beginning, on, off. That won't work. So I need to insert a delay. So I grab this delay icon on the left here, I drag it in, and I double click on that. Now microcontrollers, they work very quickly. So you can see here, we can tell it to do it in seconds, we can tell it in milliseconds or microseconds. Now, I want this to be pretty visual to the human eye, so I'm going to click seconds. Again, here you've got on, off. If I click play, you can see there it flashes on and then it ends. It doesn't go back off, so it just flashes on and then it stays on. Now, what I want to do is I want to copy, I want to turn it off essentially. So I'm going to go to the output there, I'm going to copy it, and I'm going to paste it back there. And what I've done there is basically the ports and the pin remain the same. I just need to change the variable to 0, so that will then get turned to off. and I'm going to add another delay. So paste that there. So now what we've got is on, second delay, off, second delay, and then it'll stay off. Make sure that works. Click play. Look on the right hand side. It flashes on and off. Do that again if you missed it. So it flashes on, delay, off. Now, I want it to flash on and off repeatedly. So what I'm going to do is I'm going to get a loop, and I'm going to drag that program into the, and I'm going to set that to while one. So while one, it's always going to flash until you tell it to stop. So you put that there, and I click play, and look there on the right hand side, you've got your LED flashing. Okay, now that's a very simple program. That is probably the most simple program you will do. But I could have done that literally within 30 seconds to a minute. Now, if I want to show you something, I want to stop that, and I'm going to go to debug, and I'm going to go to show as C code. Now, there's the C. So you can have it side by side with the flowchart, so you can see this here is the C. You can actually go in there and edit that if you've got students that are at that level. You can edit the C and you can input C, and you can see it side by side. Now also you can build and compile to C, view C should I say. Here you can see that getting a student to be able to write this compared to doing it in a flowchart is going to be a lot more difficult. So the flowchart has, really does speed up the process of doing that program. So that's a simple program. I'm going to show you one that's a bit more tricky that you may well get in your exam. I'm just going to swap over my screens. So stop share. Again, guys, if you have any questions, please feel free to shout them out or write them in the box there. Okay. So I'm going to open this program that's been written is how you could use a temperature or humidity sensor. Okay, so here you've got a call component macro that calls the LCD screen here. Again, this is now calling the cursor. To be honest, guys, I didn't write this, but there are a lot of detailed help in the workbooks that I'm sure you'll be able to use. It calls the print string. Print string basically means that it's going to start talking to text. If I click play here, you'll see down the right hand side it's got the temperature there. Now again, this is in simulation. In real life, you would have to heat up the temperature or cool down the temperature for the temperature to change, or the humidity. I'm going to change this temperature here and put it up to 70 degrees. You'll see here that the temperature has changed. So in this, you've got a couple of component macros. You've got a loop there. You've got a decision. And then again, you've got a call component macro. And then you've got a delay of 500 milliseconds. And then you've got the end. Now, I'm going to click stop there, and I'm going to build that and view the C. Now, I appreciate that flowchart may look a bit daunting, but I also would argue not in comparison to the C for your students that I'm sure will not be at that level, at least straight away. If you look down the right hand side, I'm probably a quarter of the way down that code. Interestingly, we do have some colleges that do want to get involved with C. Flowcode is a great intermediate step that has great graphical simulation that goes hand in hand with that C. Okay, so you can input the C here. I can pull that here, and actually there. Oh, sorry, that's a comment. I'll delete that. This here is a C. So here you type that, and you actually will enter your C code there. But the advantage of doing it in Flowcode is that you can then simulate it to make sure it works. Okay. So that's Flowcode. I'm going to show you some hardware quickly. Let me just swap screens again. You should be able to see that camera. I'm going to show you the hardware and how it and the props and the way it would come for you guys. Okay. I just need to change the microphone, so you should be able to hear me better.
Let me just make sure you can see me. One moment. Okay, guys, hi. So all the kits that we make, they come in this rugged but portable box. So this one I've got here is the BTEC microcontroller kit. Again, we want it to be as rugged and hardware as possible. So we put it in these boxes, which are Gratnell's standard. So that's important because a lot of colleges, they don't actually have a dedicated lab for this unit, because obviously you've got a lot of other labs to deal, a lot of other units to deal with. So it's quite important that this is portable. So we do actually do trolleys where you could collect a whole class set of Unit 6 equipment, just to add to that portability. Okay, so here in the top you will find all the components that it comes with. So you've got things like, this is the Grove sensor motherboard, just an example of how that works. You get your motherboard, you attach it using these wires, and then this is a relay sensor, and you would plug that in there, and that's how you would attach the motors, the sensors, should I say. Things like, you've got your ultrasonic sensor there. That's a keypad, LCD, etc. Now, the main thing that I wanted to show you is this is the rugged baseboard. So you can see how you get an Arduino, you get a PIC, and suddenly you've got to connect all the pins manually. This is a quick plug and play job. So it's literally plugged straight in, and I can't tell you how much time that will save you, particularly in a time-pressured exam. So they come on this mounted baseboard, which has got the schematic of the microcontroller, the target microcontroller. In this case, it's a PIC, and it's got, above that, you can't actually get to that. It's got a plastic cover on, so you can't get to the microcontroller, which is soldered into the motherboard. And then it's all about plugging in your downstream boards to create the system you want. Okay. Now, guys, I am going to answer any questions you might have. I think I've covered everything I wanted to. Prices and things like that I will send on a follow-up email, but I'm going to take 5-10 minutes now to just go and read if there is any questions. Also, if you would like to just unmute yourself now and ask any questions that way, that's fine as well. Okay, so one question I think one of my colleagues has already answered. You can actually convert the flowchart to C. I believe that's what the question says. Yeah, hi Somanath. I believe my colleague has answered that question. If you can't read the chat, basically you can convert C to flowchart and simulate C. Yes. Any more questions? So I'll give it a couple of minutes before I end this meeting. Like I say, I will send you a recording of the meeting. I will send you the slides. I will send you the lesson plans and teacher's notes for this unit as well. Sorry, just move that slightly. And I will also send you the prices for the kits and the software. Like I say, Flowcode comes in 3 different licenses. There's a 1 user, a 10 user, or a 50 user license. If you go for the 50 user site license, you will get 100 home user licenses as well. If you go for the 10 user license, you will get 20 student home user licenses. Again, that's really big with the current climate. We don't know how long we're going to get with hands-on with our students. So you can set tasks on your VLE or through email, and they can be cracking on at home using Flowcode, which is a real massive benefit of Flowcode. And they can also access the lesson plans and teachers' notes online from at home as well. And the simulation in Flowcode, again, makes it really, really useful to be able to students to be simulating everything at home without actually having to get the hands-on hardware that you will need for the exam. Just let me have a check to see if there's any more questions. Sorry, yes, there's been a question from Joshua about, we also have a block system. So there's 3 different systems you can use in Flowcode. One is the flow chart, which I showed you. Another one is a block method, where you can basically build blocks and you basically build a program by adding blocks together. That's another method that you can use in Flowcode. The next one is a pseudocode, where it's basically commands. I'm not totally sure. I don't know too much about the pseudocode. The next one is the C code, where you can actually input your C and you can make your program via the C. Okay, I hope that answers your question, Joshua. Just a minute's warning, guys. I'm going to give it another minute, and if there's no more questions, I will end the meeting. Now is the right time. Alternatively, if you've got any questions further down the line or about pricing or how we can help you guys individually, then please let me know. And
why'd you put your hands up?
You click that thing and lift your hands.
hello?
Where is it with your hands? This.
Maybe they've done.
Hello.
Hello.
Yeah, this is Ray Green from City of Westminster College. We have your kit, but my question is more about support for things like doing software interrupt on the Arduino. I find that whilst there are a lot of videos there on YouTube, well, not a lot, a few, and they are helpful, when it comes to doing some of the more intricate things, like when you run out of interrupts, things that you could do in C, but now you want to do in Flowcode.
Okay.
There should be a way of doing them in Flowcode. I can't find any material on that. And I know you've got a forum. I don't find the forum very useful. And not only me, others of my colleagues have not found it very useful. So how can we get some real technical help, especially when it comes to not the hardware, to the software issues, such as dealing with like software interrupts when you've run out of hardware interrupts on the Arduino, the more technical things that will make developing the software much easier.
Okay, to tell you the truth, Ray, I'm actually not a programmer. I don't know much about interrupts. I certainly don't know about running out of interrupts. If you have any sort of more technical pressing questions, if you were to send them to me, I will get you an answer. Okay,
so you'll get us an answer. Is there, okay, all right. So the other question is, you've obviously gone to great efforts to develop stuff and put it on YouTube, which is they're very good. Is there, so what I really want to know is, can we make requests for other things to be developed that would be a little bit more useful? Because whilst some of those are really good, I have no issues, but some of them can be a little bit simplistic.
Okay, I mean, I can't say, if you were to come up with an idea, Ray, and say, this is what I'd like to see on YouTube, I don't see, I can't say we'll do them all, but I'm sure. No,
obviously not. But I'm thinking of more things like, obviously you've developed this course to help with the Unit 6 exactly. on the BTEC, yeah? So it'd be nice suggestion if Matrix were to look at some of those questions that BTEC has presented to the students,
Yes.
and maybe address one or two of them, so
On
that
YouTube.
we could see on, well, if not on YouTube, even in your beautiful notes that you produce, you know, those handouts that you produce, they'd be really helpful.
Okay, I mean,
this is just suggestion. This would, if you can do things like that, I reckon that, I mean, this thing will sell itself. That's the only reason where it falls short.
okay, well,
Yeah.
I mean, that's really useful feedback, Ray. What I will do is, as I say, if we do videos on YouTube and or Flowcode, I'm not at a level where I would be doing that, because that's not my role. But
Perfectly understand. This is just.
what I will do is I will pass that on. I mean, if you, Ray, if you could send me maybe an example of something that you think would be useful on YouTube, if you send that to me, I will go to the engineers and say, look, I've had this feedback. This is what they want. Let's make the dream happen.
All right, fine. Thank you very much. I will send. Yeah, your email information, is that, where do we pick that up?
I think I have your email address, Ray. After this,
Yes.
I will send an email to all the participants. And if you wanted to just reply to that saying, this is what I've taken from BTEC, it'd be great if you could do a video on this. Then I don't see why that would, be too hard. I think that'd be quite easy for us to do.
Okay. All right. Fine. Brilliant. Thanks very much.
Okay.
Thank you.
Thanks for your questions, Ray. Very useful.
Yeah. All right. Fine. Thank you.
No problem. One more moment, guys. I'm just going to give it another minute to see if there's any more questions, or if you've got any questions, please do put it in the chat, or unmute yourself as well. I think you can see in the chat there, Ray, one of my colleagues is actually answering questions, and yeah, it seems like, great feedback. Thank you. Guys, I think that it's dried up for questions. I'll give you another 10 seconds. Now is the time to ask. If not, I'm going to end the meeting. Superb, guys. I think we're going to call that a do. It was very. I hope it's been useful for you. It was very nice to put something on for you guys. Like I said to Ray, if you do have any questions, or if you think something may be helpful, we do have support, we do have training, we are here to help. Please just get in contact with me, and I will send you a follow-up this afternoon, a follow-up from this webinar. Okay, thanks for joining, guys, and speak soon. Cheers.